Hello, friends. We have started our third unit, and in the third unit, we have seen the basic concepts of the metallurgy. Then we have seen the concentration of the ores. The concentration of the ore means making the ore in the powdered form by the crushing and the sizing. And then we have started a physical method. So we have seen the froth flotation method. The second is called as the magnetic separation or electromagnetic separation process. Now, magnetic separation or electromagnetic separation process. The name itself, magnet, tells us that we are going to separate the magnetic and the non-magnetic particles. This method is one of the method which is being used to separate the both magnetic and the non-magnetic particles in a various field, that is in the mining field. We can say the principle, as we have seen, the magnetic separation process itself tells what would be its principle is very simple, that it separates out the magnetic and the non-magnetic ore particles. So let's have a look. This method is based on the principle of magnetic and non-magnetic behavior of the ore and the impurities, which are separated by passing on the magnet. The process is used specially for separating magnetic impurities from non-magnetic ore particles or the vice versa. It's very simple, that itself the name tells us that we are separating the magnetic and the non-magnetic ores particles, or it's vice versa, by using the magnet. Now I would like to remember you a simple example. When you were in school, at that time there was an experiment, a simple experiment, that in a tray there was a sand and there was an iron nail. How they are being separated? It was a simple method told to you by our teachers, that we have to take a magnet. So when we take a magnet, what used to happen, that the iron nails, they would attract towards the magnet, whereas the sand, it would remain in the tray. So this was the method. The principle was the same, that it separated the magnetic and the non-magnet. But in engineering, what we are going to do, we are doing the same thing, but here we are going to separate the ore particles, that is the magnetic and the non-magnetic. So let's have a look towards the diagram. This is a hopper. So from here we are going to pass the powdered ore. Then this powdered ore is being passed on a conveyor belt. So this is called as your conveyor belt. These two are the rollers, that is the magnetic roller. So when we pass the powdered ore, what will happen? This powdered ore, when passed on the conveyor belt through the to the magnetic roller, the magnetic and the non-magnetic, these two ore particles will get separate while passing through the roller. This is because of the centrifugal force. The non-magnetic particles or the ore particle, they get collected in a different tank in a heap, whereas the magnetic particle, they will be near the roller in a separate heap. Now these two are being collected in the different tank. This is just because of the centrifugal force. Because of the centrifugal force, the non-magnetic particle will be away, whereas due to this magnetic, because of the weak magnetic field, what will happen? they will not stick on the roller, they will fall in the hip near the roller. So this was one of the explanation to you people about the magnetic separation process. Now, it is used specially for separating magnetic impurities from non-magnetic ore particles. The example is the tin stone, in which tin stone is non-magnetic, while the impurities iron and manganese tungstates, these are the magnetic in nature, whereas the tin stone is the non-magnetic. The impurities which are being present in that, they are nothing but they are magnetic in nature, and we are going to separate the magnetic and the non-magnetic by using the magnetic separation process. So as I've told you before, the explanation about the magnetic separation, same, we are going to pass this tin store through the hopper, powdered tin stone through the hopper. What will happen? They will pass in a conveyor belt and then through the magnetic roller. So when it will pass through the magnetic roller, what will happen? The magnetic ore particles and the non-magnetic ore particles, they both will separate itself because of the centrifugal force. These non-magnetic will be collected in the different tank, whereas the magnetic will collect near the magnetic roller. Here they does not stick to the magnetic roller because of the weak field. They get collected in the different tank and in a hip. So this was an example for the tin stone, in which we are getting the magnetic and the non-magnetic. Non-magnetic are nothing but these are the impurities which are present in the tin stone ore. The powdered ore containing the associated magnetic impurities is made to fall from a hopper on a belt moving over electromagnetic roller. So this is the electromagnetic roller, and this is the hopper from where the powdered ore is passed on a conveyor belt. The magnetic impurities fall from the belt in a hip near the magnet due to attraction, while the non-magnetic concentrated ore falls in a separate hip away from the magnet. Now this magnetic and non-magnetic, they fall near and away. This is due to the influence of the centrifugal force. So when the centrifugal force is that, it falls away from the body, that is the magnetic roller. So as I have told you before, the example is the tin stone, which is an ore of tin and in which tin stone is non-magnet, while the impurities like tungstates of iron and manganese are magnetic in nature. So here there is a formula for the manganese tungstate, MnWO4, whereas for iron it is FeWO4. So these two are magnetic in nature, whereas the tin stone is non-magnet, and these two are being separated by using the magnetic separation process. So in the previous lecture we have told you that there are three methods: Froth flotation method, magnetic separation method, and the gravity method. So the different types of ores are present, and we are using the different methods to separate the ore particles depending upon its nature. So this was all about the magnetic separation process, in which we are going to separate the magnetic and non-magnetic ore particles. Thank you.